For the first tutorial of this series, let's tackle the rock generator. It has a nice little node setup with just over a handful of nodes and a modifier UI with a couple of parameters that you can tweak. And it gives you a lot of variety in shapes, as you can see as I change the seed parameter around. And yeah, you have a couple of settings that you can set up. Before we actually dive in and create the node setup though, I want to quickly explain what this is based on so you already have an idea where we're going to go with this. So the most important part of the setup here is this detail level. And if I crank this back to 1, you can see that this is basically just a distorted icosphere as you know it from the primitives. And the idea with this detail level is that every level adds another icosphere that subtracts from the shape and creates these cuts on the outside. And as I increase the detail level here, you can see that more and more parts of the rock are cut away, and that's creating these facets all over the surface. And the result of this gives a broad variety in the size of the faces and a lot of n-gons and smaller cuts, which I really like for the look of this. So now that you know where we were going with this, let's jump right in. Just one more thing before we start. For all the videos in the series, I'm going to be assuming that you have the Node Wrangler add-on enabled, so you can follow along with the instructions and the shortcuts. Okay, great. So we started with the default cube as in any tutorial. And because we're going to be working with the geometry nodes, we switch to the geometry nodes workspace that already has a viewport, the spreadsheet view to inspect the data, and the canvas for the node editing setup. So right away we can just add a new geometry nodes node tree by clicking the new button here, and that automatically creates a modifier that references this node tree on the object. For this tutorial, we're not actually going to be using the geometry of the default cube, so we can just cut this connection by holding down Control and dragging with the right mouse button. Instead, we're going to be using the icosphere. So we can just type into the search menu icosphere and connect this to the output. And there it is. This is going to be the basis for the rock generator. So I already explained what the idea here is. So let's just start with the very brute force, simple implementation of this. You're going to need the icosphere, and as an operation, we're going to need a mesh boolean. And the idea here is to create an intersection of multiple icospheres. So for now, let me just duplicate this node, and then we connect both of them to the mesh boolean. We can do that because this node input here is a multi-input socket. It can receive multiple different inputs, however many you would like. And if I connect this to the output, we don't see any change because it's just the same icosphere 2 times. So for one of them, let me add in a transform node and then rotate it around. And you can see, we already see some effect where they're intersecting, which creates these facets. Let me actually increase how much we can see them by turning on the cavity shading for the solid viewport. Now there's already one concept that's very important to how geometry nodes work that I can make use of to simplify this node tree. These 2 icosphere nodes that I have here have the exact same inputs. And that means that the mesh that they give me are also going to be the exact same. So here, instead of using 2 nodes, I can just use the same icosphere, transform it once, and then let it intersect with its untransformed self. Just like this. And the result is the exact same. I can basically make a duplication of the geometry of the sphere however many times I'd like whenever I use this socket in another place. So if I just transform it an additional time, I can also let that intersect with the rest, as you can see here. And it all comes just from a single icosphere node. But this is still a very brute force way of doing things. Right now, we're not really making good use of the procedural system because we're just plugging in manual inputs and then having everything just very rigid on these 3 icospheres right now. Instead, I would like to have a dynamic count of icospheres and random inputs for the rotation. So let's go a couple of steps back here. Instead of making copies of this icosphere by using it multiple times in the node tree, I'm going to make use of a trick that you probably already know from other places in Blender. For example, this object that we're working on is inside of a collection, and that means that we can make instances of this collection and place them around the scene. These objects here are not simply copies of the main object. The fact that they're instances means that they're simply just referring back to this object. So every change that is made on this object will be reflected in the other ones as well. But in turn, the objects can be transformed on their own as well. And with geometry nodes, we can, inside of the geometry node system, also make use of instances. The main node that we're going to be using for this is called the Instance on Points node. As you can see, this has a bunch of inputs, but the most important ones for now are the points and the instance input. The points input can receive any geometry that has any association with points. For example, a point cloud, but also just a mesh with its vertices. So for example, we can just take this icosphere and use it as a point cloud to instance, let's say, another icosphere on top of. If I connect this to the output, you can see we have a bunch of intersecting icospheres. Let me just change the radius. Then I can see it better. So this icosphere here, it creates a new icosphere instance on each of its vertices. And the instance geometry could be absolutely anything. Let's say a cube. This concept is very useful because that means we can just scatter around a bunch of geometries in a dynamic way. If I, for example, increase the subdivision of the icosphere, it creates more points and more instances. But let's not get carried away with the cube distribution here. Instead, let's get started with the actual setup. I will remove the transform nodes here. And for now, I will keep the Boolean around. And the icosphere is actually going to be our instance object. Now we just need points that we can create the instances on. In this case, I just want all of the icospheres to be in the same place, but receive a different rotation and scale. So the easiest way to create a bunch of points that are in the same place is to create a mesh line node. This just gives us a line with a certain number of vertices that we can set, and each vertex has an offset from the previous one. Just connect this to the output. You can see how this creates a line. But if I just set the offset to 0, that means that all of the points are in the same place. Right now we can't see them anymore, but in the spreadsheet and the mouse over, you can see they're still there. So if I connect it here and the instances output to the modifier output, you can see, well, still one icosphere because they're all in the exact same place. But as I just wiggle this parameter here, you can see they're all there. Okay, so the next thing is going to be to randomize the inputs of the rotation and the scale. So So to add a random vector to the rotation, let's just drag the output here. You can see the plus popping up. That means there's going to be a new node, and type in random value. That automatically picks the vector output because that is the node socket that we need. And here we just want to create any random rotation vector. So for all of these, I will just type in 2 times pi, because that is the maximum rotation in radians, and will give us a completely random orientation. And as you can already see, this is quite the mess right now. But we can just simply decrease the number of icospheres to whatever amount we want to make it a little bit more readable. So now we're already quite far with the setup. Let's just include the mesh boolean node. And this already automatically creates a nice intersection between all of the different instances of the icospheres. This is already going in the right direction, but right now the rock looks just very round and smooth. So additionally to randomizing the rotation, I also want to randomize the scale. And because the scale is a vector, as soon as we start scaling the icospheres in a non-uniform way, we're going to get more flat and more interesting shapes in general. If we just scale them uniformly, it's going to stay around. But the randomization will already take care of this. So we just plug this into the scale, and right now it's very extreme because the maximum is still set to 6.2. Instead, let's just put it to 1. And it's still very extreme because we have the range of scaling factors between 0 and 1. Let's just take a look at the icospheres without the boolean. You can see that there's a very high variety in shapes. But in the end, what's left is just the smallest part of this scaling here. So to get a less extreme result, crank up the minimum to about 0.5, and that looks a little bit more manageable. And now we already have the heart of this node tree set up. The only thing that is left to make this modifier actually usable is to add a bunch of parameters that make sense to control this in a nice way. In the beginning of the video, I deleted the group input node, which now we're going to need back. So let me just add it in the group category. But instead of using the geometry input, which by the way is still the default cube, I'm going to create a new input from one of our settings. And the first one is going to be the count. And as you can see, now it pops up in the modifier interface over here. To change how that looks, we can open up the properties with N, go to the group tab, and here we have the inputs and outputs of our modifier. So for the count, we can just change the name right here. And if you remember, this was called the detail level in my example. The default is automatically set, being what this was before I connected it. And 6 is reasonable because it's still quite performant. To make this input a little bit nicer, we can just move it over here and press Ctrl H to hide any unused sockets. We can do the same thing with the mesh line, as these inputs are not used. That makes it a little bit more clean. And now to the next input, that's just going to be the radius. So I connect it here. Same thing, hiding it. The radius can just stay as it is. It has the default of 1 meter and is called radius, which makes sense. So we leave it as that. Next thing is going to be a seed parameter. The seed is going to be important to be able to get a random variation of the asset. So I'm just going to connect the seed of the random rotation, which is exposed as default 0. That's good. And I'm also going to use the seed for the scale. But now there's one thing to consider. As these two nodes are right now using the exact same seed, the vectors that they're generating will also be connected to each other. This is not very dramatic in this case, but in general, I would recommend you to actually add a math node and add 1 to the seed for the next node, because then you get a different random variation. I hide this again. And now we have the seed value to change the random variation of the rock. There is one last thing that I had in my example that I want to add here, which is a parameter for the roundness of the result. If you remember, in the beginning we had the minimum of the random scaling at 0, which gave us very characteristic results with a lot of flat end results. Sometimes it's also very interesting to get, so I want to add this functionality back. And to get this, we can just create an input for this minimum value. So I move this out of the way, create another duplicate of the group input, connect it to the minimum here. And now this is not very user-friendly because it's just called min and has a vector input. Instead, I just want to simplify the input by making it a float instead. Just a single value, and I'm going to call this roundness, because that's basically what it gives you. And I also want to change the clamping of the value, because right now you can go anywhere between negative and positive infinity, and that doesn't make a lot of sense. I only want to go between 0 and 1. And now this is much better to use. Let me again hide this, and there we go. This is the setup that I also had in the beginning. We can change the detail level, which will make the modifier less performant. It's going to be a little bit slower, but it will give you more cuts. We can change the roundness to get some more interesting results in the shapes. And of course, we can change the seed to get random different results. And now you can very easily use this as an asset and create a library by just duplicating it, changing the seed until you find something that you find interesting, and just keep going with that process. One last thing I want to do to make this node tree a little bit more readable is just clean it up a little bit by adding some panels. Just press Ctrl J to add the frame and F2 to name it. This one is random transforms. This is the instance. And these here are the points. Okay, great. This marks the first result of this tutorial series. This was the most simple use case example, and we're going to go more complex from here. But I hope it was a good insight into how the system works in general. There is actually one last thing to do that I almost forgot about, which is to add a material to the object. You will notice that if you try to add a material just the regular way, by editing it here in the Material tab, the material that you select here is not actually being used by the object. The reason for that is that the geometry inside of the node tree is completely newly generated. And the material slots here are connected to the data, which means to the mesh, and a new mesh will come with a new empty material slot. There is one thing you can do for this, which is to change the material slot to object linking. Then you can select a material that you like. Another thing to do here would be to add the material directly in the node tree itself. That will make the material part of the asset. Let me just add a set material node. And you can see here there is a material data block selection. We can also choose the material. And that will just set it to every single asset that is using this node tree. These two different workflows come with their own benefits, and it's up to you to decide which one you prefer. Right now here, I would like to just add this material to the node tree itself. Let's call it rock. And for the surface, I'm just going to replace this with a simple diffuse shader that has a gray tone. I will also add this to the viewport display. Maybe brighten it up a little bit. And there we go. All right, I hope you liked it, and I'll see you in the next video.